Okay, good evening, guys. Welcome back. We will continue with our Docker session today. So today is Docker-Day 2 session. Guys, because of some internet issue, right? Yesterday I was not able to take the session. So today we will start with the day 2 session. So day 1 session, I think some of them have missed it. So I would request them to go through the recording. Yeah, the recording is already there in the YouTube. You can go through it, or else I will share the drive. You can download that video and you can watch it. Okay. Day 1, not that much. Like we had just covered about like how exactly like we used to build an application, right? Like sometime 20 to 25 years back, right? That's a some kind of history we had discussed it, right? And today we're going to explore more and more in Docker today. Okay. So guys, post the completion of this session, today's session, right? You please stick for 5 minutes more after the class completes, right? Then we will discuss about like what would be our journey in in the Docker, how we are going to cover up all the topics, everything, and whether it will be weekends or weekdays, timings, all such things we can sort it out today. So that like we'll not have any confusion, and we will try to stick to whatever we have fixed it. Is it fine with everyone? So after the class complete, not now, after the class completes, we can just sit for 5 minutes, discuss about the timing and everything, and how we can proceed with completing. Because Docker, when we have started the Docker is also not a very small topic. It's a very big topic, right? Most of you are aware that it's a very big topic, and we need to cover many things. So obviously, it needs more and more time to spend on this Docker also. Okay. Fine. So today, guys, today is a Docker-Day 2 session, and the date is today is 2nd of March 2025, and the timing is evening 8:07 p.m. IST. Okay. So before we start today's session, like we will try to see what exactly we had covered in the day 1 session. That's the first session. So in a day 1 session, guys, we were trying to understand before getting into understanding what is Docker is all about. Docker is a container technology. We know that, right? And before we getting into the Docker, first we need to understand very well like how exactly earlier the applications were developed. So we categorized, it means that we started seeing the evolution of running the application. It means that how exactly we were building an application, right? What kind of a method we were choosing to build an application, and how we are deploying it. So all such history we were discussing in our first session. And we saw that, and we also took an example of something like we try to develop a ticketing system, right, where we can sell the tickets either through online or through offline or whichever way, right? And there are many customers are there, right, who sell the ticket. It could be a ticket which is sold by the cinemas, or it could be a ticket which is sold by the metros, or it could be a ticket which is sold by the railways or air ticket. It could be any client who uses ticket systems. So that's what we just took an example, and we understood like what are the ways we can develop this application. So if you go with the way back like 20-25 years back, right? So we were developing these applications, and then like we were deploying this application into the physical server actually, right? So we had a physical server. We used to go to the market and buy some physical servers like HP's Superdome server, or Dell server, or Cisco server, or else EMC servers. There are many vendors out there who sell these servers, physical servers, right? So we used to go and we used to buy it, set up everything in our company's data center. And later what happened, right? We used to set up all the things, whatever the necessary software stack required for us to develop deploy that application, right? So all such things we used to do it. So that's what, if you see this diagram, you can understand that these are the physical servers you bought it. On top of it, right, we'll go with installing any operating system. And on top of this operating system, like suppose we are taking with the Linux, we used to even deploy, or we used to even install the application server, right? So something like a Tomcat server, and on top of the Tomcat server, we used to go and deploy our ticketing application, right? This is what we used to do earlier, long back actually. And similarly, what happened, right? Whenever this ticketing application, it want to store any data, so there is to be a database, right? And even for that database also, what we used to do, we used to go and procure a physical server. Okay, we used to install some operating system, say it could be Linux, Red Hat, or Windows, anything. And on top of that, we used to go and install the database, like something like a MySQL database, and do all kind of a connections. And later, what we do, that we will try to do a DB connections with the application, with an application to the database server. So in that case, what happened? Your application start communicating with your database. Okay, okay, this was something way back, like in early 2000 or something, in early 1990s, right? Like say, for example, 1995, 97, this was the model which was used. So slowly what happened, right? So we saw that there were so many disadvantages were there, right? Because like during the peak time, like for example, your application is, the usage or utilization of the application is very going very high. Lot of traffic or lot of traffic is incoming. It means that more and more users or customers are using the same application. So in that case, what happened, right? Your whatever the physical server which you have bought it, and whatever we get the resource from that. Say for example, we get a 4 CPU, 16 GB of RAM, and 1 TB of hard drive. This is the this is what the hardware we used to get. So this was not sufficient for the application to run, because that as and when the users were growing and more incoming traffic was coming, so the the utilization of this resources used to go very high, and basically what happened is the application was stopped working. So guys, one thing, I guess somebody has come. Just a minute, hold a second. ಪರವಾಗಿಲ್ಲ, ಬನ್ನಿ ಬನ್ನಿ ಬನ್ನಿ, ಪರವಾಗಿಲ್ಲ, ಏನ್ ಬೇಗ ಬಂದಿಲ್ಲ, ಬೇಜಾರು ಮಾಡ್ಕೊಳ. ಇಲ್ಲ ಇಲ್ಲ, ಅಲ್ಲಿ ಇದು ಮಾಡ್ಬೇಕು. ಅದೇ ಗೊತ್ತಾಯ್ತು. ನಾನು ನಮ್ಮ ಮಿಸ್ ಆಗ್ತದೆ ಆ ಥರದಲ್ಲಿ ಬಂದು ಇಲ್ಲ ಮಾಡಿ. Sorry guys, as usual, the milkman. This person comes sometime morning, some kind evening. Uh, Not sure what to do. I told him to stick it one time. He won't listen. Okay, so that's okay. So what is the disadvantage? What we saw in this? It means that whenever your application, whenever the application more and more traffic is coming in, more and more customer base are increasing for application. Obviously, in whichever server your application is running, right, that server cannot withstand so much of can say so much of load into it actually. So that's the reason what happened, right? You are tend to go and increase one more server actually. And again, if you are increasing one more server, it means that you are investing money to buy a hardware actually, right? So if you buy a hardware, again, what happened? You have to do the same setup in this server also. It means that you have to go and install it. You have to even install the software stack, what is required. Say, for example, you have to install Java, you have to install Tomcat. And after at the top, we used to go and install, we used to go and deploy our application. And we need to form some kind of a clustering, so that what happened, right? Whenever the incoming traffic comes, it has to that whatever the incoming request comes, that has to be equally divided across these two servers now, right? And assume that for some reasons, right, the number of custom get decreases or the traffic, incoming traffic will get reduced, right? So in that case, what happened? Whichever the new server which you are deployed now, right? This or with these two servers, right? Whatever the traffic coming in, we don't need both servers. We need only one server. It means that you already invested so much money, the capex money for buying and everything, managing, maintaining. You have even increased your number of resources also to manage all these things. And suddenly you could see that there will be a decrease in the traffic, and the number of users who are accessing your application will also get decreased. Assume that. Then in that case, what happened? Whatever the amount you have invested, right? So that would be kind of a waste, right? A return on investment. With that, if you whatever the investment you did, if you're not getting on time the returns on that, and right, if it is not getting benefited, then there's huge loss will be there. So in that case, what happened, right? You have to go and reduce it, but for reducing the servers, basically what happened, right? You are losing the money actually. So these are certain kind of a disadvantages which we saw in the physical servers actually. And later what happened, right, after some time, and this is what the generation one, if you see it actually in the notes I mentioned the generation, this was the first most can say generation one, which was used way back, where we were deploying and developing and deploying the application into the physical server itself. Later what happened, right, after some time we came across something like a generation 2, which was very very I can say like a very new technology which came in a very early 2000, like something like 2002 2003, something during that time this virtualization came into the picture. And this we call as something like a hyperversion. So according to the diagram, what we do basically, like, we take on physical server, and onto the physical server with whatever the physical server whatever the hardware resource which has, right? What we used to do, we used to go and install the hypervisor software. So this hypervisor software was one which provides the virtualization concept. It means that if you install this hypervisor, you can able to achieve all kind of a virtualization. Virtualization means what? Dividing this whole resources, whatever the device resources is provided by the physical server, right? Dividing across many of the virtual machine instance. That is what we call it as a virtualization. And this virtualization was a very new technology which was evolved during that time. And Microsoft has designed its own virtualization. It calls a hypervisor. Similarly, like VMware is a company which designed this virtualization, which they call as a VMware ESX clients or ESX server like that, or vSphere we say. So these are the some companies which came forward and they designed their own virtualization technology. And what they do, right? Basically, they go and install in the physical server. Now, on above the hypervisor or above your virtualization, what happened, right? You used to create some virtual machines actually. And in the virtual machine, what happened, right? In the virtual machine, what you used to do that you used to get, you can go and install your Ubuntu server or your operating system, and on top of it, you can install your middleware or the platform stack, whatever it requires. Say, for example, Java and Tomcat you have to install, and finally at the end, you used to go and deploy your application. So this is something like where what happened, right? Like the earlier one, what happened, the disadvantage which we saw, right? If we are running this application into this server, say for example, this ticketing application which we are running in this physical server, you say that I want to have one more instance of the same application running. So you cannot run the same instance of application. Even during that time, people were hesitant to run some other application onto the same production environment. I think in the last session I had mentioned one thing that even in the real time, what happened, right? If you go to many of the organizations where they're using, still they're using some physical servers, you will see that in that single physical server, only one application will be running. They will not even allow any other application to run, right? So because why they want to do that? Because there should not be any kind of a clash or any kind of a resource utilization, too much resource utilization happening between this application. They don't want to see all such things. That's the reason what happened, right? Even though you have such a large server and even though your application requires very little resource to run, right? Say for example, if your server is a 4 core CPU, and if it is a 32 gig RAM, okay, and it is 5 terabyte hard drive, you know that this is what the hardware which is provided by a server, or this is a configuration which is provided by a server. But still, if you see that when you deploy application, your application might use just one virtual CPU or one CPU, and your it might use hardly some few MBs, save some 500 or 600 MB of your RAM memory, and it might use something 1 terabyte of disk for doing all the operations. Then in that case, guys, whatever the extra resource which is there, right, that is just that is free and it is not at all used at all. So companies were ready to sacrifice even the hardware loss also. They see that, okay, even though so much resources are getting lost, I am not worried about that. I'm only worried that my application should run properly without any downtime. This was something where earlier, very long back, people used to think that when they were deploying this application to physical onto the production moment, which was into the physical servers. So now what happened? Slowly, what happened? The days are gone because that they understood, right? Investing on the hardware is really it requires a lot of capex, it requires a lot of cost, and plus the main important thing that after investing the hardware for the hardware and all, maintainability becomes very very costly. You need to manage, you need to have a cooling system, you need to provide 24 by 7 electricity, you need to make a people to work on the servers, so many large servers. It was very very huge actually. So that is what the people saw the pain, right? It is too much required, the cost is too much to manage and maintain everything. So this was the thing which they had it. And as I said, right, in one server, you cannot run the same application instance one more time because your operating system or your operating system will not allow it all to run the same instance of the same application. It never allow another instance. Now this advantage, somewhat it was actually fixed in this virtualization. Now, what virtualization say that we know that we install the virtualization, and on top of it, we create a virtual machines. We create a virtual machine, and each and every virtual machine, it will get all the hardware, everything virtually. It gets a RAM memory virtually, it gets a CPU virtually, it gets a hard drive, and also it gets your networking, everything virtually. Each and every virtual machine will get it. And in these virtual machines, you have a separate operating system. Like that, you can have a Ubuntu server or Red Hat server or whatever. You can install the software stack and you can go and deploy your application. So here what happened, guys, in our generation one also, here also, if you watch it, we have a physical server. we have to go and manually go and install the operating system, and we have to do all kind of a setup to make our application run. This was there in the generation 1. Even in the generation 2 also, it's the same thing only. But here what is happening is that instead of running only one operating system in the same physical server, we can have n number of different virtual servers, like virtual machine 1, virtual machine 2, and virtual machine 3. And every virtual machine, what happened, right? You have to go and install separately the operating system, the software stack, what is required, or the middleware, we say, and finally the application deployment. Right? So you can understand the differences, right? So there what happened physically, in physical server, only one operating system is there, where only one application instance will run. That's all. Whereas in virtualization, you can have n number of virtual machine, and each and every virtual machine has its own operating system. It could be Linux, or it could be Windows, or it could be Mac OS. Any operating system might be, right? You can have it. So now what happened? Whatever your ticketing system which was running in your generation 1, like here, you can run the same application onto the two instances. Like for example, this virtual machine 1, you can run your ticketing system. Even the virtual machine 3, here you can run the same ticketing application. So this is what one slight betterment. It means that people have started using this virtualization very well. And even today also, guys, many of the organizations are using this virtualization. This virtualization will not go anywhere. It will be there only, because we get so many benefits from this virtualization concept. Right? And even your whole cloud technology, AWS, GCP, or Azure, any cloud technology might be, all the cloud technology is standing on top of this virtualization only. Without the virtualization, you cannot do any work in the any cloud computing. Virtualization has to be there and will be there, right? It has a lot of advantages. It also has a disadvantage also, right? It also has an, any guys, any module take, any module you take, if you try to take any module, every model, whatever the people have designed, every model has an advantage, as also has a disadvantage also. We have to go with that. It's depend upon our requirement, whether I will go with the model 1, whether I'll go with the model 2, or whether I'll go with the model 3. Similarly, it's depend upon the customer, whether he will go with the generation 1, he will go with the generation 1, or he will go with the generation 2, or finally he'll go with the generation 3. So we are yet to discuss about generation 3. That's what we had stopped in our last session. But we will discuss even about the generation 3 also now. Clear? So every model or every generation has its own advantage, disadvantage. It's all depend upon the requirement we choose that particular generation. So many of the customers are there, companies are there, where they're going with the virtualization only. And it is good also, because they'll get so many advantages. One of the biggest disadvantage in the hypervisor is that it saves your hardware utilization. There will be very, very minimal wastage of your hardware resources. It means that hypervisor, with the hypervisor, a user can able to make use of this hardware resources, whatever the server provides, right, to the maximum extent he can use it. But of course, even though we use with the maximum extent, still we see that there will be some kind of a wastage will be there actually at the end, right? It is not that 100% we will utilize it. Maybe like up to 90% we can utilize it. 10% anyhow get wasted. We are not worried about it. Okay, fine, we'll say, right? Okay, sir, good. Now, this is what was happening nicely all these years, and from 2003 onwards, and 2003 to 2013, like 10 years, the solid 10 years, 2003, 2002 to 2013, till some 10 to 11 years, the whole market was mainly dependent upon this virtualization only, right? Now what happened, right? In the generation 3, or you can say that from 2013 onwards, there was something which came across, which is nothing but the generation 3. So what I'll do from here, I will start with generation 3 with the second day 2 node section. So what is the generation 3 now? Okay, fine. Now what generation 3 says about actually, if you watch this diagram carefully, we said, okay, sir, we are making your ticketing system running, right? That means that your application will start running. But what exactly your application is required to run? It requires a Tomcat server to run. It means that it understands, okay, I need a Tomcat server to run. And for the Tomcat, what it needs some operating system to run. And for the operating system, what it needs some kind of hardware resources to run. So there is something like a dependency is there, right? With one each other. There's a dependencies, of course, right? Now, but as being I'm an end user, I'm a developer, okay, I have developed this ticketing system. My worry is that actually I'm more concentrate about this application only. Why I need to bother about the operating system, or why I need to bother about some other software stacks? I need not to bother at all. I am not bothered. I'm only bothered about my application. right? So it means that actually there is something like where we don't need some unnecessary stuffs actually, right? There are many other unnecessary stuffs are there which will be a part of operating system, which I'm not really worried about. I'm worried only about my application and what my application is depend upon. It depends upon something like a Tomcat server. Yeah, the Tomcat server is there. It needs some kind of a binaries or libraries. It requires some kind of other dependencies also required for my application to run. Yeah, I'm only worried about those dependencies and one application server which is Tomcat. This much is I'm worried about. Apart from that, rest other things, many other things are there, like operating system is there, or many other stuffs are there, which I'm not worried about. This is what something a shift went into something like people started thinking in that way actually. That means that you need to be more on the application, you need to concentrate more on the application side rather than the hardware side or rather than the operating system side. This is what guys which lead into something known as a containerization technology. So generation 3 is all about your containerization technology. Right now what we say is that actually what we say that, say for example, I think I have to draw a diagram everything else to show this example. Okay, this is what we have, fine. Okay, so we say that okay, now I'm not really worried about the physical server or something. Okay, but still yes, I have to have a physical server, no doubt in that. Assume that I will go with something like, okay, what is it actually. Uh, so- yeah, I have to go with the physical server. So let me choose this physical server. So we need to have this physical server. Physical server is a must. And on top of this physical server, what we can do that we will install an operating system. We will install an operating system. It could be Linux or it could be Windows, anything. Particularly for us to understand about the third generation, let us choose the Linux itself as an operating system which we have installed onto this machine. Okay. So now, and we know that as part of this, like we will get all kind of resources. I think I have to search for again, like virtual CPU clip art. Yeah. So we will get the CPU along with your hardware. We will also get the uh, RAM memory along with that hardware, right? These are all the hardwares you get it. What else you get, guys? You will get a virtual, I'm sorry, virtual network card, right? We will get even the virtual network also we'll get, or else what I mean, we will get a physical card, which is nothing but the network card what we get along with this hardware I'm saying, and also like if you you'll also get the hard drive also, right? Hard disk also, hard disk, right? We will get all these components or all these hardwares we'll get with that physical server. Fine. So now what we do basically, so same thing. You have an operating system. This is a physical server, guys. This is a physical server. This is a physical server. Okay, let me write down here. Physical server. Now the same stuff, what you say that, okay, Rajesh, whatever you have this physical server, let me take this one more instance of the same physical server. You have one more instance of the same physical server. Okay, I think let me have to move here. I'm not sure whether I'll be able to move it or not. Sorry. Okay. Now this is also physical server where like we'll have the same thing. We'll procure a physical server. Here, what we'll do, guys, we will try to install a operating system, right? Instead of not operating system, hypervisor. Sorry, we'll install the hypervisor. Hypervisor is what virtual agent. Like for example, your VMware hypervisor or VMware, we'll try to install it actually. And both are physical server. And on top of this operating system, what we do basically, we will try to install one more software, what we call that as a Docker actually. We'll try to install a software by name Docker. Here also what we do basically, like we will try to create one virtual machine, like for example, virtual machine, VIRTUL, virtual machine clipart. So I will install one virtual machine, or I'll create a virtual machine here on top of this hypervisor. So in this virtual machine, what I will do that I will go and install an operating system. Say I will install the Ubuntu Linux. I'll install the Linux. And on top of this Linux, you can go and install your one more software, which we call it as a Docker. So my idea behind saying that actually that you can install Docker either in the physical server directly or even into the virtual machine also. Anywhere you can install Docker, Docker will successfully will install. It means that it can install on any environment, right? Now, what they say that actually, you guys, what we say that, and is it fine? So after that, what we say that on top of this Docker, right? What we do that we can create an isolated area, something like this. I'll create an area like this. This is something like an isolated area, right? An isolated area. I will take a right. Yeah, this is an isolated area. So what we call this, we call it as an isolated area. So in Docker, we call it as isolated area. So with the help of a Docker software, which you have installed on top of this operating system, we will get an isolated area, right? And now what happened, right? As per our previous diagram, what happened, right? Here you could see that in the physical server, we used to have an operating system. On top of that, we used to install the Tomcat. And on top of the Tomcat, we used to go and deploy our ticketing server. Same thing we can even do here also. We can come over here. What we can do that, we can actually basically go and you can have Tomcat to be installed in this isolated area. Tomcat. And on top of it, what we can do that we can go and we can deploy our application, which is nothing but your ticketing system application. Am I clear on this, sir? Same thing what happened, right? You can have one more isolated area like this. Can have one more isolated area like this. Sorry, like this. And then like what happened, right? You can go and install your MySQL or database, right? You can go and you can have your database here deployed in this isolated area, and that what are the database you are doing, you are installing or you are deploying is a MySQL server, MySQL database server. Now, what I'm trying to tell here that guys actually with the help of something was a Docker, which we are still not aware what is a Docker, we will see. With the help of a Docker, we are able to create some isolated area like this. And inside that isolated area, we can able to run our application. How we used to do earlier, like how we used to run our application ticketing system and the database onto the physical server into the generation one. The same thing in the generation two, we used to do the same thing, but here what happened? We have an hypervisor, right? On top of the hypervisor, we were installing our virtual machine, and inside the virtual machine, we are used to install all the operating system, the software stack, and finally we used to go and deploy the application. Even this way also we were doing it in the second generation. In the third generation, right? What happened, right? We saw something known as a contagion technology, where by installing some software. So Docker is a software, or Docker is a company which has designed this contagion technology. But actually, to true sense, Docker is not the company who has invented the contagion. No, it is not the one which has invented it. It is something like where this company has made the process of creating this contagion to very simple actually. Right? That's what Docker is doing. Docker is not creating the container. Docker has not invented the contagion technology. Contagion technology was something, it was already existing in the Linux kernel itself actually, right? So what these people did, we will discuss about the history about all this Docker in some time. But what these people did, the people who were designing this Docker, right? They understood the feature about the Linux kernel, that the Linux kernel actually it is providing the contagion technology. So they utilize it and they try to build their own application, a PaaS application. So during that process, actually, they came up with this Docker contagion technology. That's what it happened like that. Actually, it happened it's not like by mistake. It happened by something. It happened something by surprise. They were doing something. The outcome what they got is something actually, and that outcome what they got was a Docker container actually, or the Docker software, right? So we will discuss about that everything later actually. Okay, so now here what has happened now, guys? Here one very important thing is that actually that now whatever your physical server which is having all this hardware, like for example CPU, your RAM memory, your networking, or the hard disk, right? Whatever you are having, what happens when it comes to Docker, or what happens when it comes to isolated area? So if you ask me, Rajesh, what is this isolated area? Isolated is area is something like this is nothing but your containerization. It is not but the containerization. It is something like a namespace, we can say. It's something like a region or namespace where your Docker will allow an application to run in that namespace or in that area. That we call it as an isolated area. Okay. Who creates this isolated area? The Docker itself will create an isolated area. Now, as part of this, what exactly Docker is doing actually? Docker will create an isolated area. Fine. Once the isolated area created, what happened, right? Virtually, your isolated area, it gets a virtual CPU. It gets a virtual CPU like this. Virtually, it gets some CPU, right? And even it virtually gets the RAM memory. It also gets virtually a network and virtual hardware. All these things, virtually it is going to get it. Who's going to get it? This virtual area is going to get it. So it means that, Rajesh, every isolated area or the containers, does it get all these things virtually? Yes, sir, it gets virtually like this. Even this container also get all these things virtually. So it means that when our application is running, the application needs what exactly it requires? It requires a Tomcat server to run. Fine, right? And it means that the dependency of this application that it needs a Tomcat. Yeah, Tomcat is there. It is up and running. Yeah, very good. So Tomcat needs what? Tomcat need? Tomcat need a Java. Tomcat need an operating system. So what Docker says that for every container, what it is creating, right? It provides a very, very thin layer of operating system. It provides a very thin layer. This is something like a very thin layer. It is a very thin layer of operating system. Sorry, I don't have space, man. Thin layer of operating system. It gets a very thin layer of operating system. So what this operating system, thin layer of operating system does. Now, whenever the application, it needs some hardware resource, say for example, it needs a RAM memory, it needs a virtual memory, or it needs a hard disk, or it needs a CPU. So what your ticketing system application will do that, it will try to communicate with that thin layer of operating system which has very thin layer. So it will try to communicate with this thin layer. Now this thin layer, what it intend do that, it will try to communicate with your Docker, which is running here. And this Docker is going to finally communicate with your operating system, right? So something like that. So it means that every isolated area or every container, it has its own small thin operating system layer. So what it doesn't do any fancy things actually. It's a very small thin layer which will be created, will be there under each and every container. And that it doesn't do any kind of a decision by its own. It cannot decide anything. It has to talk to the Docker. That's how they have designed it. And Docker finally will depend upon the operating system where it is running, right? And here Linux kernel is the one which is decided, which is working. So whatever the operation it does actually, finally the operating system one which has to do the communication. Now in that case, if you ask me, then what is this, Rajesh? Then whatever they have created, what is Docker? See, Docker is something like they have written a program actually. It's a program. They've written a program actually. Or you can say as an application only. Program or the application, which is tightly, tightly integrated with the operating with the kernel actually. Tightly integrated with the Linux kernel, right? So now so what Docker will do, that Docker will make sure that it creates this container technology whenever user is required, right? It's a very, very easy way. So what they do is that they have written so many libraries that actually with the help of these libraries, the process of they have created so many libraries that with the help of this library, the process of creating container was become very easy. the process of creating the container got very easy. Earlier, this was not the case. This was not the case. So this was not the case. It means that earlier, whenever you want to create a container, right, you need to write a huge C program. Suppose you say that, Rajesh, I want to create a container. Okay, I want to achieve this container technology before Docker. I'm saying before Docker, before 2013. So what happened, right? You used to write a big C program. So C program is to write. You have to write a big C program code. You have to write it. So with the help of a C program only, what happened, right? The container you can create it actually. So it means that it was hard. Only the developer are the one who develop, who can able to write the C program and run this container. 1 second, guys. Sorry, guys. So what I'm trying to tell that, guys, it was little complex to create a container before 2013 because you need an actual developer to run this container, means that to create it, because they used to write the C program, big C program, 100, 200 lines of code to just create one container. What Docker company did that, they made this process very simple. With the help of a simple commands, you can create a container. You need not to really become a developer, or you know to be a developer to create a container. That was a simplicity which was brought by the Docker. Did you understood, everyone? Guys, do you have any questions
Yes.
here?
No.
Okay, so that's what happened before 2013, right? When there was no containerization technology, when Docker doesn't exist, before that, companies like Google, right? They used to create a lot of containers in their at their workplace. It means that in fact, most of the products, whatever Google had developed earlier, like in way back in 2009, 2010 onwards or 2008 onwards, they were literally running their, their products, everything onto the container technology only. But how they do it actually? They used to do means they used to write a program itself, separate program itself. It could be either in C or C++ language. They used to write the program, and that program is to create a container. And inside that container, they were running their products. Google were running the products. It was right. That was the case actually, and people were not aware of that. Google was doing such activity actually, and Google were very smart people. They used to do all these things, right? See, we don't know many things. So many things Google is doing. Google is also indirectly doing so many programs for our NASA space station also. Like, but the people around the world, people are not aware of what Google is doing. Google is not only building the products; they are actually doing a lot of innovation activity in many fields. Actually, they are doing in the environment, like they are doing some very fantastic program they are running for conserving the water, everything in this world, right? They are running the program in the back end. They are doing it in the space technology. They are doing it in the irrigation and in the agriculture. They are working, but we are not aware of it, right? We don't know exactly. So that's how the Google is very smart people. They are doing many things actually for the humankind, as well as for themselves to run the company, as well as for the humankind also. They are doing many projects they are running, right? So now, so what we got to know, so what exactly this ticketing application, for it, whatever it needs, all the resources it is getting in our Tomcat server, where it can run it. It also getting all the hardware required, what is required. So when this application is running, it is thinking as if like I'm running in the physical server only, but it doesn't know that it is actually running inside a container. It is not aware of it. So that's how they have beautifully designed it actually. Am I clear on this, sir? Right? So now whenever you create, whenever Docker want to create any container, that container is nothing but it's an isolated area. So what is this isolated area is about? We'll discuss about that one later. What is this namespaces? I coined some word as a namespace actually. So we have different namespaces are there. What are these things? These are very quite interesting. And these days in many of the interviews, they started asking even these questions also. What is isolated area? What is C group? What is file system namespace? Right? What is network namespace? Right? What is the process identifier namespace? Process tree namespace? So many things they have started asking because they want to see that how much this person know in depth in Docker technology. That's the only thing they are asking. Too many things now, right? So now what has happened is actually that one good thing happened with the Docker container is that actually that it always uses very minimal thing actually, very minimal thing. See, for your application to run, what is it requires? It requires only the Tomcat server. Apart from that, any other thing is required, nothing. So it doesn't need anything. So it will always try to keep it as minimal as possible. You don't need any kind of other things at all. Say, for example, like in my system, this is my Windows operating system, right? If I open the terminal, if I open the terminal, and if I want to ping, I want to use the ping utility, I'll just say ping google.com. See, so it means that actually what happened, the ping package is installed in my Windows and I'm able to ping it actually so that this command works and I can use these commands because we have installed the package. That's the reason I'm getting this command. Otherwise, if I don't install the package, if I try to say ping Google, it says that ping not found. It means that the command not found. It means that that relevant package is not installed. Now, this is something, it is my desktop where I've installed surplus packages, everything, whatever. I might use some packages or I might use many of the commands in my lifetime, or there are many other commands which I don't use at all in my lifetime. But still what happened, it is installed in your system. It is there in your system and it is up and running. But whereas in case of a containment technology, it doesn't need all those fancy commands. It doesn't need all those fancy libraries. It doesn't need many dependencies. It doesn't need at all because your application is whatever the minimal thing which requires, only that thing will be available inside the container. Say for example, if you go inside this container and if you try to say ping, if you try to ping, you say ping google.com. So what it throw error, it will throw as a command not found, right? You will say that Rajesh, I want that file, or if the file is that if that particular file is there or not. You go and check it, that file will not be there. Hey, then how it is running? It's not like that, man. You are having a very minimal thin layer operating system is there, which is very minimal. As I said, this minimal thin layer, it doesn't actually do any kind of an operation by itself. It always communicates with your Docker, and finally the Docker will communicate with the operating system. So this thin layer is something like it always takes some request from that application what it needs, and finally it sends the request to the Docker itself actually. And the Docker finally sends a request to the operating system, right? So now, so it is something that is a very minimalistic thing which is required. It is something like for a human, what is a very minimalistic thing requirement? We need water, we need air, we need food, we need some good clothes to wear. That's all right. Any other thing is required? No, we don't need any other thing. That's all. So we can leave our job with a very minimalist thing also. We can stay or we can live in the life, right? So it's something like I'm not sure how many people are aware. Like in the Netflix, there was an movie was there. What is that? Minimalistic actually. Mini. What is it actually? Minimalist Netflix movie. So this is the movie actually. Minimalist actually, minimalist. This is less is now. So this movie, if you watch, no, they will show you like what is the least thing which you require to live in the life. It's exactly same thing like in this container also. So the container says that actually that what you need it, only that much is sufficient for us to run, right? So that much will be there actually. Am I clear on this, sir? So shall we see what? So your generation 3 is nothing but it is a containerization, which is nothing but the Docker. So now the question comes, Rajesh, why you are saying Docker only as a container? There are many other tools are there, like apart from Docker. For example, you have a Rocket container, is there, Rocket is there, Podman is there. Why you say Docker only? Is it something Docker has took a trademark of contagion? Not like that, guys. Contagion is something like which actually made very easy for an end user, right? That everything was built by the Docker only. Docker is a company which build the container in a very easy way, so that you and me or anyone without any knowledge, much knowledge, we can create a container, right? Same thing, like for example, whenever you talk about the virtualization, the first thing comes to your mind is VMware, right? Does it mean that VMware was a company which created the virtualization? No, it's some other company which created. But VMware made it so much simple that everyone started using VMware to achieve any kind of a virtualization you need it, you can use it actually. So that's what they made it very simple. Same thing, Docker is one company, Docker Inc. company is the one which actually made the things very simple way. Even Google couldn't do it, but Docker did it actually, right? So that's what Docker, how they did it, everything, as I said, right? They have written the libraries, they have written many kind of libraries, many things, libraries which are written. With the help of the libraries, you can able to create a container with just a few command, the few command line you can able to create it actually, right? That's okay. Now, right? So what is the third generation we say? So in the third thing that in the Docker, actually, whenever you install a Docker, you get something known as a container engine. Okay, you'll get a container, which is nothing but Docker, like a Docker can be installed on any operating system. You can take Linux, you can take Mac. Earlier, what happened? That earlier Microsoft was not supporting. Microsoft Windows, Microsoft, right? Microsoft Windows was not supporting the Docker directly because they initially hesitated to uh, add on the Docker technology into their operating system. Later, what happened? What Microsoft saw that they saw the popularity of the Docker. They thought that okay, Docker is leading everywhere, and most of the companies are using Docker heavily at their work, everything. So that's what happened, right? This Microsoft, which usually doesn't entertain any kind of a code change in their operating system to support some other third-party software, right? They doesn't do it actually. So then when they realize it, when Satya Nadella realized that okay, Docker has become too much popular, so what he did, like he contacted to the Docker company and you said that you please send our engineers, we will have a discussion towards that, we can partner together. So Microsoft and Docker company, they partnered together. The engineers went to the Microsoft company, they explained the whole thing. So what they did, right, for the first time Microsoft company, they took a Windows operating system, which is number Windows 10 operating system. They added a lot of codes into the Windows operating system. A lot of kernel APIs were added into it. And finally, what happened that your Windows operating went from Windows 10 onwards and from Windows 2016 server onwards, they added this Docker container into their operating system itself so that you can create a container very easily. This is what happened. So as I said, right, Microsoft is not the one which actually allows all the things happen, but due to the popularity of the Docker, right, they were forced to do a lot of changes into their operating system kernel. They added so many codes, and then that operating system started supporting the. Am I clear, answer? Linux by default from very long back it was supporting actually. It was supporting Docker and all. In fact, as I said, right, when the Linux kernel came into the when the Linux kernel was designed by the Linus Torvalds. So Linus Torvalds is a guy who designed the Linux kernel or the Linux operating system. By default, the Linux operating system itself had the containers actually, but nobody realized it actually. And the company which realized it was the Google actually. Google as a one which they saw that there's some special feature is already existing this Linux kernel. Why don't we utilize it actually? They utilize that special feature and they made it to run as a container. So it means that from the way long back when the Linux kernel was designed in 1992 by Linus Torvalds, right, and many of the open source contributor, but main contributor was Torvalds itself because the Linux kernel, there are two important, very very two important subsystem of the Linux kernel is one is a file system and other is a memory management. These two components were completely written by Linus Torvalds itself. He's the only guy who written both his component and memory management in any operating system and as well as the file system plays a very 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 vital role in an operating system so these two complete subsystem were written by him. That's what the whole credit of the Linux design goes to Linus Torvalds itself. We still call him as a father of Linux only, right? But there were many other contributors who were there who contribute for the device management, who contribute for the process management, who contributed for the network management. There are many other subsystem of Linux operating system is there where people contributed it, right? But what happened? The main core was this Linux Torvalds itself. Now, when Linus Torvalds designed the whole Linux kernel and everything, he redesigned everything from the Unix operating system. He took the Unix operating system concept, and when he started designing it, he without his aware, there was a containers within the Linux kernel. That feature was already there when they designed it. He was not aware of it. But who recognized it? The Google recognized it. And who evolved it? Actually, the Docker company evolved it actually. This is what it happened actually. And even when the Linux came into picture, when they evolved it, of course, Linux community, they created their own container they call as a Linux Alexis actually. Alexis. Linux has its own container. Now we call the Linux Alexis. Linux containers, we say, right? That way back, after some time they did it actually, but it was there already, as I said, okay? Now, come back here. So the container engine like Docker can be installed on any operating system. That's what, as per the diagram, guys, you can have installed the Docker here only, or else you can even install the Docker on top of your hypervisor. Anywhere you can install, the Docker will support actually, right? Okay. Now, what else? So what is a container? Container is an isolated area. That's what I said. Isolated area, which contains everything necessary to run your application. That's what we say isolated area or the container. Am I clear, sir? Okay. So what are the advantages actually? So one of the very important, one of the most advantage when it goes to containers, the containers are highly portable. Containers are extremely portable, you can say, right? It's an extremely portable, right? So you can port your container anywhere, right? You can see when you are running your application or when you're having a Docker container on top of your physical server where it is running all these things on premises. You can take this container or you can take this container of the isolated area. You can go and you can even run in your cloud technology also. It means it is highly portable. Okay. Rajesh, can I take this container and can I go and install into something which we call it as a Raspberry? Have you heard of it? Something about this? Raspberry uh, ARM boards. See, you can take this. This is the board actually, right? This is the ARM board or ARM 11 or ARM 9 boards actually. Here, what you can do that this is a small board actually. You can go and you can even deploy your container here also in this Raspberry Pi. We call it PI, Raspberry Pi ARM single board, SBC we say, single board computer. You can even run your application here also because you can even port your application here also. So that is a kind of an advantage you are going to get it actually if you design anything in a container technology. It means that it's highly portable. See, this board is something, guys. You might have seen that what people do that they'll take this ARM 9 or ARM 11 board. You can have your Linux operating system, a customized Linux operating system. You can have on top of the Linux operating system. You can actually create a containerization. You can install a Docker, and onto the Docker, you can create an isolated area or the Docker container, and you can run your application. A small application you can run here actually, and you can take the same board and fit in your inside your AC. So what happened, right? This will control your whole AC. Like a user is increasing the temperature, decreasing the cooling, or whatever you're doing, every operation will be taken care by this board only, a small board. So the same small board, even it is there in your RO also. Suppose in my home, we have a RO, right? We have a Kent RO. Inside a Kent RO also, we have a very, very small, board actually. Like for example, we have something known as a Beagle board. I don't know how many are aware of it actually. Beagle board. Very small, sir, Beagle board. Beagle BOARD board. This is simple small. This bigger board, Rajesh, it looks like as if this is a mobile. Yes, sir. It's a mobile. If you open the mobile, right, inside the mobile, you'll find this bigger board actually. So it's a very small compared to Raspberry. It is very, very small actually. Here you can go, you can run your application. Have you heard about something as an IoT, Internet of Things? So where did it run? Where the IoT applications run? All this application runs here in the sir. Either in the Beagle board or either in your Raspberry Pi, right? Or either in the Adreno. Like I think you have heard about Adreno, right? AUDRINO. Adreno board. These people say that Arduino board is a very, very cheapest board available in the market. This is an Arduino board, very small, sir, this much size. You can run your application here also. So here what happened, right? You can have your operating system running, a very thin operating system running, a very small operating system, not like a very big operating system, very small. You'll customize it. That how do you customize it? We use some process known the kernel compilation. Kernel compilation is there, and or else you can use some kind of a I think you have heard about something known as a the build process, we say Yocto build process. Using with the help of a Yocto build process, operating system, dependency, libraries, all the things you can customize it. You can create a very small kernel where you can go and you can port it this kernel. So we call it as a porting. We say port means you have to go and burn this operating system into this chip actually. Once you do it, once your operating system is up and running, once this board gets initialized, once the operating system up and running, you can go and install the Docker, and on top of the Docker, you can go and create a container also. And that container, that contains something like where you're running your IoT applications, right? Say for example, like you will be having, you need to measure some data, right? You need to measure some 6 months of data, right? You'll be having your IoT application running, and that IoT application, whatever it is designed, you can design in any language. It can be Java, it can be a REST API, it can be Python, it can be Nodes, any language you can choose to write an application when it comes to the container. That is the beauty of the container, that it is uh, independent. You can choose any language which you want. Guys, any doubt so far here? Dan? Prem Amrit.
So,
Okay.
Rajesh, you say the container is an isolated area, right? I've been
Mhm.
following. If I miss it, you can please repeat yourself. So it's an isolated area of what?
I just said, sir, I'll expand. I'll explain more about this later, sir. Don't worry, because we have not started anything on Docker, right? So I just said that Docker is going to create an isolated area which is nothing but it's a container only. So every container is an isolated area. It gets its own memory. It gets its own namespaces. It gets its own file system. It gets its own thin layer operating system. That all together we call as an isolated area. Along with that, you'll also get a virtual memory, virtual hard drive, virtual networking, virtual CPU. Everything you'll get virtually. Everything for each and every container. A small piece of all this hardware information also will be given to each and every container. That is all together we call it as an isolated area.
Okay, yeah, thank you. Yeah, that makes sense.
Anyhow,
So
we will
it takes
discuss.
yeah, it takes that fraction, that bits and pieces from the mother machine, right? So like
Yes,
this Docker,
obviously. Yes, yes,
obviously,
right.
yeah.
Correct. What you said is right. See how it is going to create all these things actually. How it gets creates all this thing. There is something the Linux kernel which provides a feature which we call it as a namespaces actually. Namespace is something which we'll be discussing, as well as there is something like a C groups. So this concept is which comes from the operating system level itself. So what Docker does, Docker is nicely using this namespace and C groups to create this isolated area. And how it is doing all these things with the help of this library. What are the library or program which is written by the Docker, right? This Docker is something like an application user. It's a solid application which the Docker company has written. That will utilize all the nice features of the Linux kernel, and with very easily way you can create this isolated area with the help of only with the command line only you can do it actually. That is the beauty which the Docker has brought in. Right? So now you say that Rajesh, Docker is the one who has actually invented this container technology. No, Docker has not invented the contagion technology. That contagion technology was already the part of the operating system itself, the Linux kernel. Only they identified it and they tried to make it in a very simplified way. That is a good thing which they have Docker did it, and we cannot discount that Docker didn't do anything. Docker has did many things. But what is happening is that actually that they made it in a very, very easy way, sir. Very easy way, very convenient way, where people, any end user without any programming language, anything, he still can create the containers, right? And that is what the beauty, right? Whenever the things become very simple and it comes to your on hand, right, then it becomes very simple for us actually, right, to use it actually. We need not to really worry about in the back end what technology is going on, how it is doing. We need not to worry as an end user. Oh, I am able to make use of it. Oh, that is sufficient for me, right? Something, for example, I want to just give an example like in India, right? There's a Ola cab facility there. Ola is a company which was started by Bhavish Agarwal. He's an IIT. He was working in Microsoft in US. He came to India and he saw that actually the cab system, the taxis are there actually in India. But what happened? There was no process where like you can easily hire the cabs. And you can get it. Like for example, in way back in 2004, 2005, right? I'm just saying it's very long back. We never used to get a cab at all. Actually, we have to go and book it 2 3 hours before itself. We have to book it, and like if it comes or not, we don't know. There are some standard people are there, some cab facility people is their office that we have to go and book it, saying that okay, I need a cab for me to go to airport. It was very difficult, sir. People were not managing. It was very difficult. You need to have a we need to have a people, a dedicated people who will listen to you and they will come and they'll provide the cab facility for you. It was very, very difficult. When Bhavish Agarwal came back to India, like in 2010 onwards, when he worked in Microsoft for a period of 4 5 years, he saw the difficulty that still in India, where Europe and US and all have so much progress, in India we are facing this problem. What he did, sir, he did a very streamlined way. He did what he did. He created an application itself, right? The whole application. He made it to design. He made it to run and under the physical server, right? That application. And later, what happened? Right? He made it very easy, so that people can log in it with a very simple process of just giving your mobile number and taking an OTP. You'll get authenticated to your application. You need not to give all details about your address, this, that, everything. Simple, with a number, it gets authentication, you get an OTP. And finally, what happened at, with the very, very easy process, you can go and you can book your cab actually. And that cab, what happened, as soon as you book, now that cab will be arriving at your doorstep only. So now the thing is that what has happened, right? Do you think that all these cab systems was designed by Bhavishakar? No, the cab was there. Even earlier also cab was there. Now what has happened, right? There was a necessity that he want to make the process very simple. That's the reason what happened. He designed this Ola application. And now what happened? Ola application also can be installed even in mobile also, in your Android or in your Apple OS, anywhere, and you can make use of it. It's only the process he has made it very streamlined. Same thing, the Docker also. So a lot of difficulties were there to create a container. So what the Docker community did, or the community did, they made it this very process very simple, so that anyone, you, me, or anyone can go and they can create the container. Clear, sir? Now you see that same Ola company, it is there in Bangalore also with thousands of people. Like earlier they started with only two people. Slowly they grown up with big number, and now you could see that they are doing a lot of work actually. They are doing many things, and one of my close friends elder brother is there in the same company from long time, since from the day when it was started, right? He's one of the core member actually there in that Ola company. So right, so that's how what happened, right? If you make things very simple process, that itself is like an innovation only. Now what Docker has did, there's, you can't say that Docker didn't do anything. Docker did many things actually, right? And even still today also Docker is doing many things. They are doing a lot of innovation. They are doing it. So that's how, guys, right? What happened, right? Things were there, but you want to make it very, very simple process, that itself will be called the innovation. Now, whatever the technology or things which is there, right? Whenever we bring any simple way out of it, actually, that is what people will file as a patent. Do you think that patent is something where an extraordinary you go and bring some knowledge? No. Already the existing knowledge only, we will try to streamline something and we'll make that process in a simple way so that you can use the technology very well. That is what we call the patent. And people, why people file a patent? Yeah, they'll file a patent actually. And who are the number one patents, guys? Which country is the number one patent who files so many patents every year? The US is the one who files so many patents, because they will be keep working on the same thing. They'll be keeping, and they'll bring something new process into that actually. And that they file it as a patent actually. Right, Dan?
Yeah.
Yeah. So US people are very smart people. They want to patent everything, right? Fine. Okay. So this is what, guys, I want to, if you want to give an analogy for you, for all the things, whatever I discussed, actually, see, if you want to give it, actually, you remember, like nowadays we have the smartphones, right? Like we have a smartphones where we can, and that smartphones works with the technology, the GSM, right? GSM technology, it works. Earlier, we used to have even the CDMA. Now CDMA is not there. We have a GSM technology where we can communicate actually over the phone. But if you remember, like long back, even today also we have, do you remember there's something like satellite phones? Do you remember? Do you see? A lot of people know they carry the satellite phones also. This is something like we had a satellite phone, guys. Now, satellite phones are something which are you can go and communicate anywhere. If you go to Antarctica also, anywhere, or the in South Pole or North Pole, anywhere in any corner, if you're in the ship also, you can actually have a communication with the help of a satellite phone actually. But do you think that this matter for a satellite phone is there with every common person? No, it is not there. Why? Because that the satellite phone is simple, it looks handy, but at the back end, it needs some kind of some big box receiver is required. A big box is required. It's a small box which is weighing around 2-3 kgs. That receiver will be there, and that has to be plugged into a power actually, right? That is what it is. It means that you can, so usually people when they all these military people, all army people and all, they'll get this satellite phones actually, and they have that receiver with the big device connected to the some battery, and they'll get the power, and you can communicate with the satellite phone anywhere in the world. You can communicate, right? So this was there actually, but still what happened, we cannot use it because of the, we need to carry one more heavy device with along with this device actually, right? But this has a lot of advantage, but it doesn't mean that the satellite phone is not used at all. It is used by many of the organizations, mostly like what are the army people or some kind of government officials where they want to communicate at any point of time, right? They will keep the satellite phones with them actually, right? So this is one kind of a communication device which is there available. And after that, I don't know whether you remember this or not. I know it. There is one device, the Tata Indicom wireless phones. I think most of you have already seen this actually. See, this is a walkie-talkie. Have you seen this, guys? This device?
Yep.
Have you seen this? In
Yep.
Bangalore, I've seen, like this phone was there around, if I'm not wrong, some 10 years back. This was there actually, 10 or 12 years back. This device was there. And what happened, right? People used to carry in the bags actually. And this used to catch the signal up to a range of 60 to 70 kilometers. If I'm in Bangalore, the Bangalore area is around 40 or 50 kilometers actually, the area actually. 40, now it is more than 50. I'm just saying some 10 years back. People used to carry this in bag. People used to carry it in the bag, and people used to sit in the buses and all. When I used to go to the college, I used to see so many people were picking from this, and they. So what happened, right? It becomes very simple actually. So people started carrying this box. But again, this is a very big box actually. It's something like a telephone only, but which it is a wireless telephone, and it can catch the signal up to 70-kilometer range. If you go beyond 70-kilometer range, right, this phone will not work. It will stop working. It means that you have to be under the limit range, city limit range only. So that was it was happening. Okay, now what happened? Slowly, what happened, guys? We came up with something as a phone actually, right? We called it with a GSM mobile phones. So GSM mobile. So now you could see that we can carry the small phone anywhere, the smartphone anywhere. We'll get the calls. We'll receive it. You can even go outside your area also. It will catch it actually, right? But if you go to some other area, say for example, if you're in the ship actually, and the ship is sailing in oceans, there you might not get signals. Or else if you go to some Himalaya region, at the top of the Himalaya region, or if you go to some Antarctica, you will not get the signals because the signal will not catch over there actually. Yeah, if you take the satellite phone, yeah, there everywhere it will catch actually. Now, what is it? Why I'm saying all these things? Because guys, it is something like whatever we saw now. The first generation was something like where we were using that uh, the satellite phones actually. This is something like generation one. Generation two is something like a wireless phone, which I showed you, right? That is something. And the third generation is a contingent technology where we are using our GSM phone, smartphones actually. So do you think that okay, was the wireless phone was wrong or was the satellite phone wrong? No, they are not wrong. They are correct only. But what has done for our convenience, it is not correct. So now what happened? Now for our convenience, right? For our requirement, we don't want to go and deploy our application into the physical server or into the virtualization. We want to go and create our application, run our application in the containerization technology. Because containers technology has more and more advantage compared to the from the other methods actually. Am I clear, sir?
Yes,
So
sir.
guys, I know I took some time, but I thought this was required actually, right? Yeah, sure, Dan, we'll do that actually. Yeah, I'll do that. I just saw your message now. Yeah, okay, thank you. Great. So coming back here, so what is an advantage? It is extremely uh, the advantage of this container. It is extremely portable. That is the advantage you get. You can take your container in any environment. You can run your application, right? And what is the disadvantage? Can anyone tell me what's the disadvantage? See, whenever you create a container, suppose whenever you create a container, containers by design are immutable and not uh, not and I can say will not support in place updates. So what it means? So you say that Rajesh, according to this diagram, I am having my ticket application which is up and running. Fine, very good, it is running. Now assume that there is some requirement comes to you where you need to do some changes into this ticketing application. Do you think that when the content is up and running, can you go and do the changes? It doesn't work out like that because by nature, the container, what is running, it is immutable. You cannot go and edit any kind of a changes into the application, or you want to add some features, you cannot do it. You have to kill that container, right? You need to build a new image, and then only you have to make that image run as a new container. So it means that you cannot do in place update. Whereas in our operating system, say for example, this is my Windows operating system. Okay, some new update comes to my Windows operating system, or some new update come to the server. So what we do, we go and we run that update. So what that update will do, that update will be keep updating. Finally, what happens, that update will ask you for the rebooting the system. Once the server or your laptop will get rebooted, once it comes up, finally your application will start working. It means that what happened, right? There is what will happen, that you can go and update any time point of time, right? It at least it lasts for the reboots. After that, your application will start working. Whereas here in the it is not like that. You cannot say that Rajesh, I've stopped this container, then edit the code changes and then make the container. It doesn't work like that. You have to take that application, add any changes, convert that application into an image, and then make that image up and running into a new container. So it means that you cannot do an in place actually. But according to me, I will not say that as an advantage. That is by design actually. It is not a disadvantage. It's a design, like it is designed in such a way that Docker say that you cannot do you cannot do in place update. You cannot do. It's not possible. You have to kill, or you have to stop the container, go back to your application. Okay, edit all that, add all the codes, whatever you want to do, create an image out of it, and then finally create a new container. So that is by design only, right? So I cannot call it as an advantage or disadvantage, but still, okay, we are categorized this under the disadvantage only, that you cannot do any changes into a running container. Yes, sir. Prem Sagar. Yes, sir. Yes, yes. You can do anything. You can take directly take wherever this container you installed, wherever you install Docker, you would have installed that. You have installed the Docker in some other EC2 instance in AWS. You have the same Docker installed into the Azure VM. You can go and directly you can make your application up and running there. You take a snapshot of this one. Just take a snapshot of it. Go to that environment. Just run that container. It will run it. Because for this, it requires a Docker actually, and Docker is there in that operating system. It will run. That and all we'll see, sir. It is very I can say that it is very interesting that I use something as a snapshot. I took a snapshot of this container, take the snapshot, and I'll try to run in some other environment where there is Docker installed. Whether my application will run or whether the container will run, yes, it will run. So that is a disadvantage. That's a beauty of the container, Docker container, which we'll see all those things, how we create a snapshot, everything, how we can make it run, everything will be seen over in some time actually. So contents being ephemeral can be an advantage and disadvantage since you can't update. Yes, sir. What you said is 100% right now. Okay. Thank you, guys. It was pretty good questions what you had asked. Okay, yes. Any other thing you have? Now, the thing is that what it has to come in your mind that, Rajesh, whenever we talk about anything about the container, it should be minimalist to minimalist thing. It means that it needs only those dependencies for which it requires that application to run. Any other things which is not required, container will not allow it, or you not to have a container. That's what we say. Docker, we call it as a thin, lightweight container. We call it a thin, lightweight. Very minimalist to very minimalistic, something like that, right? See, for example, assume that actually we know that, see, by nature my body is very fat actually. When I went to the gym, right, what that gym person told me that when I went to the gym, the trainer told me that, sir, your body is having too many masses. He said, see, he touched my stomach, he touched my hand, he said, see how many fat it is increased, sir. Why you are taking all this fat every day along with you? When you're walking, you're actually going with your body only, but you're carrying a lot of fat with you. It means that you are taking as if like you're taking extra burden with you and you're walking, right? So it is better that, sir, you have to burn this all this fat and become lean. And without any fat, you walk here, you'll feel yourself very light, you'll feel very much comfortable. So he was trying to convince me to come and join for the gym. It's same thing like that actually. When the container having, sir, whatever the minimalist thing is there, right? Only basic thing, only that much is required, sir. Any extra thing, any other dependency, any other library, any other commands, I don't need it actually, right? That's how they made it a very minimalistic. That's what we call it as a Docker container. Am I clear on this, sir?
Yes,
So
Rajesh.
is it fine?
Yep.
Okay. So what we'll do, guys, we will try to stop it now. Take 15-20 minutes break. If possible, can we have one more hour class? Or if you want to continue, I'll continue it. But I feel like I can give a break now and I will continue because I know that yesterday also missed, today also missed. I'm not sure whether you agree with this or not. Can you stay for one more hour? We are going to see some interesting thing, and for next one more hour, and then we'll stop our session. Or else I can pause this video so that there'll be a single video only with everything. Or else I can stop and I can start one more recording. What do you say? Shall we pause the
I
video?
think Yeah, maybe I think it's a full 1 day session, so maybe just make it one video. That's what I think.
Yeah, one
That's
video,
just
one more session, one more video, like that. But guys, I don't know, because it's a Sunday. I know that I am asking, but is it fine? Are you all agreed to attend 1 more hour, or is it sufficient? You'll say, no, Rajesh, we don't need. We'll see some other day. Like, what is your state? I want to know your state, because guys, when I'm taking the weekend, Saturday, Sunday, I mean, as of now, I'm saying till we complete the Ansible session. I would request that you give me more and more time on Saturday, Sunday. Suppose if I call you at evening 6, you give me up to 9 o'clock time. So the in 3 hours, let me cover 1 hour 20 minutes, 1 hour 20, like two sessions I'll cover. Remaining half an hour or 40 minutes, we'll give a break in between. Why I'm doing that? Because that every week we need to cover minimum, we need to cover 2.5 hours, 2.5 hours. Means Saturday 2.5 hours, Sunday 2.5 hours. 5 hours is a very, very fruitful time what we can spend in a weekend. Okay. Guys, I think you can.
why is everybody so quiet?
Yeah, yeah. Why everyone are quiet? Amrit, Chanakya,
Yes,
Chanakya.
sir. I can stay, sir, for one more.
Yeah, thank you. Sanjay,
Yeah.
Sanjay bhai, Sarvanan.
I can
Okay,
also.
Rajesh, you can proceed.
No, we can
Okay.
proceed or we'll give a break.
15 minutes break. After that, we can proceed. No issues.
Okay, okay. Thank you, sir. I think then I will pause the video. I'll pause this recording, sorry. And then like when we start up, when you come back, like we will continue from where we left.
Okay.
Right? Okay, sir. Let me pause the recording. I'll pause the recording. Okay, let me pause it. Okay, Dan, I will go with you. I'll completely stop the recording. So this will be a complete 1 or 1.5 hour session. One more session we'll record it after once we join back after 15 minutes. Thank you, man. Thank you for that. We'll do that. Okay, let me stop the recording now.